So, Dalton's law of partial pressure. Three different gases. Let's say there are a mixture of gases in a container. Okay? For example, Cl2, fluorine, hydrogen. Each contains their partial pressure. So, PCl2, that's the partial pressure of fluorine. PF2 is partial pressure of fluorine. pH2 is partial pressure of H2. So, what's the total pressure
Then
in
add it all
this
together.
container?
The P1 plus P2 plus P3.
Exactly. So total pressure in the container. So Dalton gave a law of partial pressure. Pt equals P1 plus P2 plus P3, so and so forth. So in that case, in this case, we can say total pressure in this container PCl2, PF2 and pH2. This means partial pressure of each particular one. So this law applies when you have a mixture of gases in a container. And you need to find total pressure exerted or single pressure, so you can find that. That's the Dalton's law of partial pressure. Okay, so let's see if we can work on one example. Dalton's law of partial pressure. Okay, let's work on that. Let's see if we can find, we don't want to work on mole fraction right now, but we can find okay, let's work on one of these problems. Okay, for example, let's say we have, I'm trying to draw, and there is a valve in here. There is a valve in here. Okay, and this is a 2 atmosphere and a 9 liter, and then this side is 3 atmosphere and 3 liter. So now let me draw it correctly. Hold on. Okay, now consider the above apparatus. Containing helium. In both sides. So there is not a mixture, but just helium at 45 degrees Celsius. Initially, the valve is closed after the valve is open, what's the pressure of helium gas? Helium gas. Alright, so there are two ways you can solve the problems. There are two ways you can solve it. Okay? Find the new pressure of the gas. So what is that? P1 V1 equals P2 V2. So initially we have let's say 2 atmosphere and 9 liter. That's the initial condition. So when we can use P1 V1 equals P2 V2. So when we plug that value, you have 2 atmosphere and 9 liter. We need to find out new pressure. But what will be the volume when you open this valve? You add them together, right? 9 liter plus 3 liter. When you add them together, you need to find a pressure 1.50 atmosphere. So that's the one way you can find. Or what you do, you can calculate a 3 atmosphere times 3 liter and then on the other side. So either way you can calculate, right? So that's where you can calculate. Now we are going to work on one more problem on Dalton's law of partial pressure. 27.4 liter of oxygen gas at 25 degrees Celsius and 1.30 atmosphere and 8.50 liter of helium gas at 25 degrees Celsius and 2 atmosphere were pumped into a tank with a volume of 5.81 liter at 25 degrees Celsius. Now we need to calculate partial pressure of oxygen, helium and total pressure of both gases. Both gases. Alright, so now we need to find for oxygen. So what we do? For oxygen, P1 V1 equals P2 V2. P1 we have 1.30 atmosphere, V1 is 27.4 liter, right? This is for oxygen and 1.30. P2 we need to find and we have 5.81 liter because that's the volume of the tank. So when you rearrange, you can find P2 6.13 atmosphere. Now the same thing we need to find for helium. When you calculate for helium, same way, P1 V1 equals P2 V2. You guys need to calculate, but you get 2.93 atmosphere. Let's calculate both together.
Huh?
Okay. Alright, let's calculate all together. Again. What is that? Go back, okay. Here we go. 2.93 atmosphere. Let's calculate for helium.
Where'd you get?
Okay, let's calculate. For oxygen we got 6.13 atmosphere, right? And for helium, let's work on it. Okay, so for helium, we are going to use P1, V1 equals P2, V2. We have 2 atmosphere and 8.50 liter. P2 we need to find, and we have 5.81 liter. That's the volume of tank. We need to find out the P2 for that. And when you rearrange and calculate 2.93 atmosphere. Now we need to find out P total. In that tank we have P partial pressure of oxygen and partial pressure of helium. We calculated for oxygen 6.13 atmosphere and 2.93 atmosphere. When you calculate, you get about 9.06 atmosphere. So total pressure in that tank is 9.06. This is the partial pressure of helium. So that way you can calculate total pressure, adding them both together. Okay?